Assalamu alaikum dear students. Today our topic is algorithm and flowchart from the syllabus computer science 10 metric. We will be talking about the steps which are involved in writing the solution of a problem. And you remember that in the last video I have given you the detail of the different steps which we follow in order to write the solution, and those are known as the problem solving steps. And from those steps, two very important steps are algorithm, and the other one is flowchart. Now, what is algorithm? Algorithm is actually a finite set of steps which, if followed, accomplish a particular task. So algorithm is just like writing the solution of the problem in known number of steps, and these steps once followed will lead to the right solution. And these steps, now they need to be very clear, they need to be finite and effective. And the simplest form of algorithm is actually the step form algorithm, just like the to-do list or the algorithm. We also can assume algorithm as the recipe of a dish, or algorithm can be the set of steps of which are involved in a practical we do in the labs. So it consists of actually sequence of number of steps. Now, what is the strategy for developing algorithm? Algorithm development involves the following major steps to carry out, and we can proceed to correct solution of a particular problem by adopting the following strategy. So what is that strategy? It involves step number 1 is the investigation, and step number 2 is preliminary algorithm, and step number 3 is refining the algorithm. Step number 1 is investigation, means when we are writing the solution and when we are writing the algorithm, we need to identify the process that will be involved in that solution, and the major decisions that you have to, or that program have to take in order to reach to that solution. And then the areas where the program will have the repetitions. Repetition means a few steps or number of steps they will be required to repeat again and again. And then identifying the variables. Variables are actually the identifiers or the variants which will hold the values. So these things we do in the step 1, and that is the investigation. And after the investigation, the preliminary algorithm is we move to the steps to step 2, and that is preliminary algorithm. And in this step we devise a high level algorithm, means a generalized form of algorithm, and we write the generalized steps that we think need to take for writing that algorithm. And then steps through the algorithm, further breakdown is done with those generalized breakdown. It means just like walkthroughs, and it reveals many major problems, any major problem, and if it does, then correct the problem. So you have to further move down in each part, and so that you can move toward the step number 3. And that step number 3 is that we refine that algorithm. And refining the algorithm means incorporate any refinement that is indicated. So when you will be you are doing walkthrough, if you have seen any major problem, then you need to refine it, and that refinement is done in the step number 3. And after refinement, so group together process where appropriate. So it is possible that different steps may relate to one process, so they need to come under that tag. Then group together variables where appropriate. Test the algorithm again by stepping through it. So this is known as refining the algorithm. Now we'll take one example how we write the step form algorithm. Like if we have to bake the cake, step 1 is that heat oven to 325 degree Fahrenheit. Step 2 is that gather the ingredients for making that cake, like flour, butter, sugar, milk, eggs. Step number 3 is that mix these ingredients thoroughly in a bowl. And step number 4 is that pour the mixture into a baking cake. 5 is that bake in the oven 50 minutes. And 6, repeat bake 5 minutes more until cake top springs back when touched in the center. So this is a kind of repetition. So you're repeating the thing again and again, and definitely you want to reach to until the cake is fully baked. And once it is baked, you cool on a rack before cutting, and then you can cut and serve it. So you can see these are the steps. This is known as step form algorithm, how we distributed the main issue of baking a cake into different steps, and they will be followed in order. So algorithm, and the order is very important. You cannot exclude, or you cannot just exempt any step from it. So you have to, it need to be in order. Again, we can see the original algorithm is that if we have to, let's say, make a tea, put tea leaves, then boil water. 3 is add water to pot, wait 5 minutes, pour tea into cup. So this is the journal. These are the journal steps in order to make a tea. And if we move toward the first refinement, putting tea leaves can be further divided into some steps. Like putting leaves means you can write open box of tea, extract 1 spoonful, put spoonful into pot, close box of tea. So putting leaf in can have these steps, and this is the first refinement. And these steps can further be refined, like step number 1 is open box of tea. So open box of tea can be further refined, like take a tea box from the shelf and remove lid from the box. So 1.1 can have 1.1.1, so it can be further redefined. So in the same way, close box of tea 1.4, it can be further refined, that it means put lid on box, replace tea box on shelf. And then 2.1, fill kettle with water. So filling kettle with water can be further refined, that involves put kettle under tap, turn on tap, wait until kettle is full, turn off tap. So add water to pot, it can be further divided. The same fill kettle, it is refined, and then switch on kettle, wait water until water boiled, and here wait until kettle whistle, and then switch off kettle. So these steps are the further refinement of boiling water. Add water to top, pour water from kettle until pot is full, wait 5 minutes, no further refinement. Pour tea in cup, pour tea from pot onto cup until cup is full. So you have seen that how we have refined the original algorithm into first and second refinement, and this is how we reach to a more clear layout of the solution, or more clear or more simplest form of the steps that can be followed in order to write the solution. Now this was the example of the journal activities, or the journal this was the journal application of algorithm. Now if we bring it to the computers and the way the computer is doing the computational task, you can see in the number system, what we can do here, find the sum, product and average of 5 given numbers. Like this is the question. An algorithm, you can see the step 1. So if we have this problem, that sum, find the sum, product and average of 5 given numbers. The algorithm says that step number 1 is start. And what mean by start? Let the 5 numbers be, A is 2, B is 5, C is 8, D is equal to 4 and E is 12. So this is starting, because in order to do the sum, product and average of 5 numbers, we initially need to have those 5 numbers, and these numbers assigned to different variants or different variables or different identifiers. So this is step number 1. Step number 2, now we have to do the sum. After having the numbers in A, B, C, D and E, we have to calculate the sum, and the step 2 is find the sum, and this can be further refined like sum is equal to A plus B plus C plus D plus E. Step number 3, find the product, and this is how we did it. Step number 4, find the average, and how we do the average. Average is equal to sum divided by 5. Step number 5, output sum, product, average. So after calculating the sum, product and average from these numbers, given numbers, now we need to output them. Sum, what will come in sum, what will come in product, what will come in average. So we are outputting it, and then the last step is stop. So this is how we write the algorithm for more technical kind of problems related to the computers. So find the volume of a cube. Again, we can do planning the solution, input length of the side of the cube, required output volume of the cube, process sides of the cube. Step number 1, start length, let the length of one side of cube be 12, calculate volume, volume is equal to length power 3 and output volume, stop, same. So after doing the algorithm, the other important part, the next important part is flowchart. So in flowchart is actually the transformation of algorithm into a pictorial form. So it is the representation of algorithm in diagrams, in terms of diagrams. It is a visually presenting the flow of data, the operation performed within the systems, and the sequence in which they are performed. So flowchart are actually more easy to understand, more easy to define a problem, the solution of a problem. The flowchart is similar to the layout plan of a building. Like if we want to construct a house, we first go to the designer or the architect and tell them to design the layout plan. They draw the diagram of the layout. So then the constructors, they follow that diagrams. In the same way, when you are creating a program or you are creating a software, initially the design layout of that solution is created, and that layout is initially written in terms of algorithm, and then it is drawn in terms of flowchart, and then those algorithms and flowcharts are given to the programmers, and they finally write the programs for it. Now the symbols which are used in flowchart, they are like this symbol, a rectangle which shows a process, a tilted rectangle which shows either input into that flowchart or output out of that flowchart, that the computer is obtaining data or outputting result. Then this box like diamond, it is decision. It is used to ask a question that can be answered in a binary format, yes or no. Every time out of this decision you get two answer, either yes or no, and these are connector. For example, if you have a big flowchart and that flowchart is reaching to the end of the page, then you will have the connector, and then on the next page you will have the connection of, you can continue the same flowchart connector. Then this box with the lines on left and right, it shows the predefined process or the subroutines. They are pre-written small programs. And then we have the terminals. Terminals means the start of the flowchart. It shows the start of the flowchart, and it shows the end of the flowchart. And flow lines, they indicate the direction of the flow of data into the flowchart. It shows how we will proceed in a flowchart. Now we'll take one example, developing a flowchart to find sum, product and average of 5 numbers, like we did in the algorithm. You can see that the start, input A, B, C, D, E. So start, it is the terminal. Start and end, you can see these are the terminal. They shows the start of the flowchart and end of the flowchart. So when it is in the start, you write start, and when the same symbol is used in the end, you write stop. It shows that the flowchart is stopped here or it is completed here. So in the start, we have input A, B, C and D. So it shows, this kind of box shows that when this solution will be written in program, it will ask for the values from the user to input in A, B, C and D. So there is no initial value assigned to A, B, C and D. It is assumed that you have created the place, or you have nominated the variables into memory to hold the values which the user will input. Like the user can assign 2 to A, he can assign 3 to B, he can assign 10 to C, he can assign D to 15 to D, and so on. So in the first step, the program will get the values from the user, and then after getting these values, and this diagram shows the input box, and then you will move toward the process part. And here you can see it is a rectangle, and in the rectangle now you are going to calculate the sum, product, and average. Sum will be calculated by adding A, B, C, D, and E. So you by adding together A, B, C, D, and E, you will get sum. By multiplying A, B, C, D, and E, you will get product, and by dividing sum by 5, you will get average. So this is the process. The process is always done on the input data, and after the process, something is calculated, generated, or something is now ready to be output, and these are sum, product, and average. So these will be they will be output in the next step, like we write output. Now here we are not writing A, B, C, D, E, because they were the variable for inputting the data, and input is always part of some process, and that process will lead to some solution, some output, and those output you are outputting here. Output is sum, product, and average. So these three things are going to be output, and definitely whenever you are doing output or input, we are using these kind of diagram, tilted rectangle, and after outputting, the program is finished and you write stop. So this is how we do the flowchart. And what are the advantages of flowchart? They help with the help of flowchart, the logic of algorithm can be described more effectively. So you can understand the algorithm, the solution more easily. The flowchart are part of design document. So maintenance activity can be done with it. Let's say you might remember that for the electronic devices, you also get a diagram manuals, and for the electrical engineers, if they want to fix some problem into it, they refer to that manual in which you have the design. So likewise, when you make a software for a company, when you hand it over, or when you install it, or you give it to that company, and for example, after running that software, if that company or the user they face any difficulty, or they give you the feedback of any error into it, or like there is any other programmer who want to fix it, your document or the flow chart will give them that guidance. Or even in the start of the solution, when you are writing a solution for very complex programs, these flow chart help to understand the logic and to find out the errors. The flowchart are also the guide for the program development, the programmer to put effort more efficiently on the underlying problem, and it helps in debugging process. Debugging process, I told you that debugging is actually finding out the errors, and these errors can be logical error, these errors can be syntax error. So in order to find out these errors, the flowchart will do this thing more easy. And the limitation is that it is difficult to draw flowchart for complex problems, and if alterations are required, the flowchart is to be redrawn. You have to redraw it. So now these are some questions in which you can see draw flowchart to find acceleration of a moving object given mass and the force applied, input force marks, acceleration force marks, output acceleration stop. And here you can see the flowchart to print odd numbers from 1 to 100, start k is equal to 1, output k is equal to k plus 2, k is less than 100. So you can see the use of the decision box and the use of repetition. So you will be learning these things in your next lectures in your programming skills. You will also, and one thing you all need to understand that in your computer syllabus of class 10s, you have to actually draw the flow chart. You should know how to draw the flow chart of every problem, of every program, or for every algorithm, or you from any flow chart you should know how to write a program. So this skill is very important in doing the problem solving or in writing the programs. So this is all for today. I hope that you have got the clear idea of using or writing flowchart algorithms and designing the flowchart. Thank you very much.